I want to thank all of you for coming this morning. I see a lot of faces of people have known for many years. I want to thank the AIAA and our ESMD folks who organized all of this and brought it together. So far it looks like it's working, and it looks like everything is going well. The objective for our meeting the next couple of days is to communicate the work that our study teams have put together in a short period of time since the budget came out in February. We put teams in place right away, and in order to get more definition and understanding and piece everything together in a more cohesive story. And at this point, I think you'll see the products of that. But it's also, one of the objective is also to get your ideas, to get your input, looking at what you see from the teams. What ideas do you have? What do you suggest? What can we do better? So as Mike mentioned, what we're talking about, and you'll hear it over and over probably, is that what you see is a point of departure. So it's a point at which we're interested in broadening the input to the process and getting more ideas. So today, this morning, we will go through a number of presentations to communicate what work we've been doing, but then we break out into breakout sessions and one-on-ones in order to actually have a working meeting, more informal, and begin to have the discussion that I mentioned. So your ideas, as well as what the teams have put together, will come together and help us understand with better fidelity what our direction should be and what priorities should be. So with that, I'll jump into the presentation. I'll be giving an overview that kind of sets the stage for what the teams are doing, talk a little bit about the budget and our overall philosophy. What you see is something that we've worked on over a period of about 4 years now. It's the themes for exploration. They represent theme areas that include many objectives for what you do on exploration missions. And they fall into these categories: sustained presence, knowledge of science and technology, economic expansion, global partnerships, and inspiration and education. This work is a product of many people from internationals to academia, industry, and NASA, and others to develop these objectives. And we have worked with 13 other space agencies through a coordinating group, international coordinating group, to come up with a global exploration strategy. So this is still at the heart of objectives for what we do in exploration. So our new path for exploration begins with the 2011 budget request. It challenges NASA to embark on a new exploration program. It has us stepping back and investing in developing knowledge and capabilities that will help in future of human spaceflight. We'll be developing new systems based on this development of new capabilities. The areas that we'll talk about today and elements of the program are first, research in heavy lift propulsion technology and supporting technologies. There's a program, there are two programs actually in general technology, one of which is the Exploration Technology Development and Demonstration Program, and our flagship technology demonstration program. We also have an area that we'll invest in, which is in exploration robotics to develop the ideas and actually conduct the missions to destinations where we'll send people to understand hazards, engineering characteristics, and get more knowledge on the places we send folks. There is also a new program in commercial crew. We have an augmentation in commercial cargo. We are developing the approach to that right now, but this is a new area, and the idea being here to help develop commercial crew capability and transportation to and from Earth orbit, so that NASA will concentrate on development of the capabilities for long-term exploration. Also in this budget, as of April 15th, the President made a speech and also included in our programs an Orion crew rescue vehicle that will provide the rescue capability from space station and provide the technological foundation for advanced spacecraft for deep space exploration. So in terms of destinations, what we'll work toward is developing these capabilities, doing the research, and developing concepts for missions and conducting missions in the early 2020s, test flights leading to exploration of a near-Earth object or asteroid in the 2025 timeframe, and with missions to the Mars environs in the mid-2030s, with eventual landing on Mars. What this will do is build on experience as we gain it in an incremental fashion, as was done in Mercury and Gemini. And although we can't talk today about an exact date for landing on Mars, we do know, and I'll point out, we do know the technologies and capabilities it takes to get there as of right now. These have been studied over many years and have been the subject of committees and commissions that have reported out on what the future of human spaceflight should be, and include recommendations from those reports that show the technologies that are included in this budget are many of those that are actually very essential for future human exploration. This chart gives an example of technologies that are very leveraging in exploration. What it represents is the amount of mass in low Earth orbit to send a single crew to Mars. And if you look near the bottom, there's a little picture of a space station, fully complete, at about 850,000 pounds as mass in low Earth orbit. With today's technology, it would take us about 12 times that mass to launch a single crew to Mars and bring them back. That gives you the idea of the gear ratios involved in going those distances, and what it would take in terms of systems and fuel in space and such. So it's pretty daunting. Space station has been an incredible assembly of pieces in space, but this would be almost beyond comprehension. So if you look at the various technologies that can address this mass in low Earth orbit, there are technologies such as cryofluid management, advanced in-space propulsion at much higher ISPs. There's closed-loop life support. There's aerobraking at Mars, all of which contribute to bringing down the mass that you have to put in Earth orbit to do the missions. These all reduce the amount of fuel generally, or reduce logistics. So there are many others, but it just gives you an idea of how we look at the priorities and the leveraging of technology in order to do these missions for the long haul. This represents a phased approach to exploration. Begins with the commercial crew activities or development that we will put in place for low Earth orbit, and phase one also includes the technology and research and early development that we have in the fiscal year 11 request. The next phase is then to build on these capabilities and develop systems for long-term exploration beyond low Earth orbit, and then the third phase being the actual test flights and missions of the future. This chart really kind of pulls together the ideas on how these fit. Basically, if you think about the destinations that we can conceive sending people to, with the bounding case really being Mars, there are capabilities that have to be developed in order to do that, along the lines of the chart I showed that showed the leveraging technologies. As we understand these destinations, we can come up with capabilities that are common to the various destinations, some that are unique to a particular location, but they all can, through system studies, we can develop concepts for these capabilities and apply technologies to see what leverage we actually can get from the technologies that we look at. So basically what we're showing is the destinations. Through mission analysis, we understand the capabilities, and through design and implementing in design modeling various technologies, we find that we get to a very important set of critical technologies that are represented in the budget that we are working. There's also the possibility of new technologies emerging over time. In our current NASA budget, we also have a technology program in the Office of Chief Technologist, and in that technology program, they will be looking at game-changing technologies and cross-cutting technologies. As the low maturity technologies are invested in and we see the potential, these could then be worked into the technology programs that are in Exploration Systems Mission Directorate. We talked about point of departure. Through these teams, we have developed the plans. What we had them do is lay out what does it take to put programs in place and processes in order to get programs underway in these various technology and capability areas. And in the cases of flagship demonstrations, in the case of robotic missions, we have candidate missions that we have pieced together to see how that fits and captures objectives. But those are all, once again, points of departure. And so it helps us in our decision making, but it provides the starting point for our discussions as we are having today. And actually, the meetings that we are having the next 2 days are the first real step in communicating what the point of departure is at this point in our planning, and once again to get your ideas and factor those in and help us understand what the real leveraging developments and capabilities we can put in place to enable the future. So what we're doing here, I think, is very important. Now, when you see these points of departure, they will be affected as we begin to understand the implementation of the Orion Crew rescue vehicle. That is not fully integrated yet into our planning. So here again, it's important to get your ideas so that we understand what the highest priorities are. The Orion rescue vehicle will be obviously paid for out of the NASA top line and will affect some of the other planning. But we still need to understand, based on our current point of departure, where we begin to develop new ideas. This chart represents all the technology lines, or all the program lines that we have, and various milestones that have been laid out in the point of departure, so that we can see how they can be integrated into a plan that leads to eventual exploration missions in the beginning of the 2020s. We, in order to understand what it takes to do these missions, we put a team in place called the Human Exploration Framework Team. It's made up of engineers and others from across the agency. It's being led by Steve Altimus, head of engineering at Johnson Space Center. His deputy is Dan Dumbacher, head of engineering at Marshall Space Flight Center. They have an integration team that actually almost all of which have worked in exploration in one way or another before, and have the integration skills to bring together results of various studies that we are undergoing. But the objective of the HEF team is to go through the mission concepts and apply those to the destinations that we talk about, and understand once again how the technologies affect those outcomes, and actually lay out design reference missions, lay out requirements and objectives for these missions. It will help us in our budget planning. It helps us to prioritize our technology programs. And so this is a list of deliverables. We are talking to our stakeholders in order to capture their objectives. We are developing guidelines for the studies based on the objectives that we get and figures of merit. And we are developing the design reference missions and supporting studies to get matured ideas on our missions and concepts and capabilities so that we can bounce them off of figures of merit and affect the selection of technologies to develop and mission concepts. This chart shows the relationship between our technology program, which is the bar with an arrow at the big bar of the arrow at the bottom. There are, as I mentioned earlier, technology programs led by the Office of Chief Technologist. Those are the game-changing technologies, cross-cutting capabilities, and basically the way we intend to operate is to try to run the gamut from early identification of technologies by academia, industry, and others into particularly into the game-changing arena, as well as to our engineering development and demonstration program. And we will work with Office of Chief Technologists through a governing board where we will divide up and conquer the development of these technologies, making sure that we cover from early emerging technologies into flight demonstrations so that we actually make the jump that often doesn't happen in technology programs where you begin a technology and it kind of dies for lack of interest or funding at some point. This process is geared toward taking it from beginning all the way through demonstration and ultimately to flight so that they can be used in our programs. Next, I'll get into center assignments. We have been through a process where we have put together what those assignments are. And this chart, I'm sure you can't read, but I'll go through the key assignments from exploration. This actually represents assignments and new programs in this year's budget they're all inclusive and not just exploration. In terms of our technologies or our program assignments, in the technology arena, the exploration technology development and demonstration program will be at Glenn Research Center. The flagship technology demonstration program will be at Johnson Space Center with the deputy from Kennedy Space Center. The exploration precursors robotic program will be led out of Marshall Space Flight Center for medium class and missions of opportunity class experiments. Ames Research Center will lead Scout mission development, which are smaller class robotic missions. The heavy lift technology and demonstrations program would be at Marshall Space Flight Center. The commercial crew program will be at Kennedy Space Center with a deputy from Johnson Space Center. All of these are assignments that we currently have. We also have participatory exploration, which is a small program that we actually are running out of the Exploration Systems Mission Directorate at this point. All of these are important new areas. Most are new areas within exploration. And at this point, in identifying points of contact at the lead centers, as we work through the budget process, they are helping to put more definition into the planning that the study teams that I mentioned earlier have put in place. So we needed this as a part of our budget planning, and so now we have centers involved and leading a lot of this activity in conjunction with our study teams. Another aspect of our programs will be more aggressive participation with international partners. We have been working, as I mentioned earlier, with International Exploration, Space Exploration Coordination Group which is an activity that has been going on with 13 other space agencies to understand each other's interest in exploration. We've begun talking with them about this new budget request and the contents of this budget. As we talk to them further, we are working to develop a more sustainable and affordable human spaceflight program with more of their participation. They have shown a lot of interest in the robotic programs that we've talked about and flagship missions, and we'll be working with them in where we can in the technology arenas as well. So we are going to continue this. We actually have a meeting coming up that's actually a step in getting a little more energy into it this summer. On June 23rd, we have basically heads of programs meeting to discuss the work of this coordination group and its future. So we are going to work with these current partners. We're going to look at expanding participation with other countries as well. And so in next steps, we obviously still have a lot of work ahead of us. Our first phase of work in this area was to do a series of studies where we developed content that you're going to see today, and the next stage then is working with a broader group of industry, academia, and internationals to get your ideas and participation in development of this idea or these program areas. We also, if you're probably aware, are putting out requests for information and broad area announcements in some of these areas. We're not able to do it across the board, but we have 3 program areas where we have current work. One is in heavy lift within our Constellation program. We were able to make some progress there, and we're putting out study requests for proposals downstream. But we have the broad area announcements out. I think we have that out as of last week. And we also have put out RFIs on almost all these areas, but we also have a broad area announcements going out on the exploration, technology development, and demonstration program. It is most closely aligned with the current technology program that we have in exploration. We also will be putting out broad area announcements in human research because the human research program is continuing through this as well. So we are, through those processes, we'll be getting more engagement from outside of NASA. We will be working further to develop through these various efforts more definition on this budget, and we work in that budget process through the fall. And once we get to a resolution between the administration and Congress on the future of exploration, we'll be working to implement the budget that we have. So all in all, we are seeking to continue exploration to extend human presence throughout the solar system. The President's FY11 budget request is focused on developing the research and capabilities and knowledge that we need to fly to various destinations beyond where we've been before. Once again, it is an effort to gain knowledge and develop capabilities to do that. So through this budget and through the work associated with it, the idea is to invest in the capabilities that we need to do these missions in the future. I do want to call attention, and hopefully we're going to do this throughout this next couple of days. I want to call your attention to the websites at the bottom of the page here. We do have an external website where we're going to continue to update information there so that you can keep up with what we're doing. We're trying to make sure that we communicate the work that's going on within this planning so that you can stay up to speed and help us through the development of the concepts and programs that we envision. So with that, that completes what I was going to say, and I don't know if you want to move on to the next speaker. Or I can, yeah, I'll start off with some questions. I know we have a panel this afternoon to do that, but if we have a few minutes, I can answer questions now. All right. Okay, over here. Time, right. It's time. I think they already are on the web. They've already been posted. Yes. Yes. I believe that's Mark. Yeah.
I have quite a few questions. Probably. I guess because basically I'm fundamentally confused about what NASA's going to be doing in the next 5 years based on the budget in your presentation and everything I've read on the webpage. It's not that they aren't all, I guess they're clear in the sense of putting all these bullets up, but I don't know where we're going, right? And I don't know why we're going to take 5 or 6 or 7 years to study heavy launch, because we built a heavy launch vehicle 30 or 40 years ago. We were building or attempting to start building one with Ares 5. So it's not really clear to me exactly, do we need to step aside and study for 5 more years before we start doing this? And also the Orion vehicle, we were already building that. Now we've stopped building it, but we're going to make it into a rescue vehicle. But then it's going to be our access to deep space for humans. Is that really the most logical and cost-effective way to go along that development path?
I think you'll get more of the answers through the day, but I'll start because you're going to see more definition on these programs. One aspect of this is that we're working out the details on timing on heavy lift, for one. In the budget this year, we had taken some budget reductions, and actually development of heavy lift had been reduced significantly over the next few years, and we weren't able to get started on it until 2015 or later. So that was that in that category. This will provide some funding to develop engines and technologies that will help make that heavy lift exploration more efficient. But we are working on with the administration on exact dates. When's the earliest, and we actually have made some progress on understanding the 2015 timeframe, and you'll probably hear more about that. We will be initiating missions in the robotic missions and the flagship demonstration missions beginning in 2011 in terms of development in order to be able to fly within the 2014-2015 timeframe. But it is stepping back and developing some of the technologies. We are working on some of those technologies currently that I showed in the charts, but at a fairly reduced rate compared to what this budget would have you do. Some of the technologies, in order to do missions beyond the moon in particular, we're just not where we need to be. So this program actually invests in the development of those capabilities at a faster rate. The crew rescue vehicle, we are working on defining exactly how that works into the program, and so we're in communication. We're in meetings and resolving some of that this week. So there's more definition of that coming.
When do you expect the flight demonstration of these new technologies?
You'll see more detail on that later today. I think the earliest ones are like in 2014 for the first demonstration. Is that correct, Mike? Yeah, that's correct. If there are questions, I can't see who's raising a hand, so I hope.
Hey, Doug.
Mark's still got his book open.
Hey, Doug. While he's waiting, I'm back here. Walt Faulkner. Hey,
Hi, Walt.
a quick question on your one chart. You're showing the Orion light on your chart. And I guess the quick question I had for you was that was not originally in the President's FY11 budget. So what part of your plan with regards to technology development and robotic precursors and so on and heavy lift will be the bill payer for that piece of it?
At this point, that is what we're working out. It will be taken, obviously, out of the budget at the top line of NASA, and but those details are being worked this week. So that's ongoing. I don't have an answer for that yet. Mark?
When you're talking about commercial human space access, there was words that they're more accessible and affordable. We can't hear you.
Hold it a little closer, please. Yeah. That's off.
Okay, we'll switch off here. All right, here we go. Commercial human access to space, more accessible and affordable. That was one of the bullets up there. So it's more accessible and affordable than the space shuttle, or more accessible and affordable than Soyuz trip. So is that part of the requirement that's going to be laid down for these commercial companies, that they have to do better than either one of those? And the other is more of an engineering question. I was really curious on that Mars slide where you showed how different technologies would ramp down the mass you need. And that starting mass is obviously, ridiculously huge, but then you got it down to something completely manageable. But I was really surprised that ISRU, making your own propellants on Mars, gave such little gain. I would have thought that would have been the biggest gain that you could possibly get, and it was really very, very small.
Yeah, let me go back to that. The way that chart it has to do with the way that chart is constructed. Basically, it starts at the top, and it gives you a percentage reduction. So each step beyond that gives you an incremental percentage reduction, so the actual magnitude looks less on the chart. If you started with ISRU, it would look as big as the first one. It is a huge driver and is actually enabling for Mars. And basically, what that means is, if you use in situ resource utilization to develop only the fuel for ascent of the Mars ascent vehicle for the crew, it has a huge effect on mass in low Earth orbit. If you had to carry that fuel all the way to Mars, take it down the surface, and then use it to get back into orbit, the multiplying effect is huge. So it's not apparent. One version of this chart used to have percentages, which actually helped understand that a little better. But it is a big driver. The biggest drivers on this chart are the cryo management, reducing boil off, aero capture, and the advanced in-space propulsion and ISRU are probably the top ones. They're all very, very large contributors to reductions in mass. And you asked about affordable and sustainable. Right now, I think it's. I think what we're saying there is that just use this chart as an example. If we tried to go to Mars right now with today's technology, the cost would be huge and almost not possible in terms of the technical part of getting everything to low Earth orbit. And so for chemical propulsion with not addressing these technologies, to say that you're going to put 13 times or 12 times the mass of space station in orbit it's not only not sustainable and not affordable, it's probably not possible. So this is an example of what those words mean. Even by applying these technologies, we're still talking, when we get it down to the bottom near, say, 1 or 2 times the mass of space station, we're still talking about 6 or 7 heavy lift vehicles, over 100 metric tons to orbit. So that's still not insignificant in terms of trying to put together a mission of that type. So that just shows the importance of these technologies.
Doug, while we're on this chart, I wanted to ask about another component that's missing, and that is radiation shielding mass. There's really not much budgeted in the DRA 5.0, and anything I look at in terms of conventional shielding mass without any other mitigating techniques indicates about 90 metric tons in low Earth orbit to shield like a transat.
Right. Actually, the research in radiation is not there are 2 components of radiation aspects of this. One is understanding the effects of radiation, which is in the Human Research Program budget, and the other part is the technology for shielding. And you're right. First off, we need to understand the effects of radiation, which we are doing. We actually, over the years, when I first started working exploration about 21 years ago, we didn't have any facility on Earth to get data for galactic cosmic radiation, and now we have it at Brookhaven National Lab, and we're beginning to get research on radiation effects of heavy ion radiation effects on human cells, and associated research. It is also going to provide us the capability to test shielding materials. Shielding is a big deal. For galactic cosmic radiation, conventional shielding doesn't really help you. It actually can make it worse, because these are heavy ions. If they hit metal, they send off secondary ions that may be more harmful than the first ones. So it's not like a solar event, which is a proton event. Shielding for that is a little more straightforward, but the shielding for galactic cosmic radiation is just a different ballgame. So you get into polyethylenes, actually hydrogen, and in terms of the design of your mission and your spacecraft, you can actually put water or fuel around the people and help protect them that way, so that you can dual use your some of the onboard materials that you have, but certainly that's going to be it's a tall pull actually in getting to these missions for long duration in that environment.
Over here.
And we do have those components in the programs.
First off, let me congratulate you and thank you guys for taking the first steps in getting NASA back to its science and technology roots and pushing in new directions. It's really refreshing to see, and change is always challenging, and we're here to support you, but thank you very much.
Thank you.
It's just leading on to this is that there's a lot of great projects out there, and there's a lot of innovation that's going on in the country and smaller companies as well as larger ones. And if you could talk a little bit about how you're going to get the big guys and the small guys together and try to push innovation for the good of the country and NASA, that'd be wonderful if you could lay that out for these programs.
Thank you, and ideas along the lines of how we do that are helpful too. We don't have all the answers. Pardon me? Okay, so I'll turn it back over to Mike. Thank you very much.